The Earth spins endlessly, completing one full rotation every day. Our bodies, our cities, everything moves along with it. This motion generates an invisible force, a massive magnetic field produced by Earth's rotation. So, could this energy be converted into electricity? If that were possible, Earth itself could become a giant generator. Just imagining it is electrifying. But for a long time, physicists have said the same thing. It's impossible. Why? To generate electricity, the magnetic flux passing through a loop of conductor must change over time. That change induces voltage and causes current to flow. This is electromagnetic induction, the basic principle behind all generators. Earth does have a massive magnetic field. In the past, scientists believed this field was fixed to the Earth's surface and rotated along with it. If that were true, the magnetic flux wouldn't change, and no current could be produced. But in the early 20th century, scientists made a surprising discovery. Some parts of Earth's magnetic field, especially the components symmetric around the rotation axis, don't actually rotate with the Earth. In other words, we're constantly passing through part of Earth's magnetic field, even when we're standing still. At first glance, this seems like it should allow us to generate electricity. Unfortunately, it doesn't work that way. As a conductor moves through Earth's magnetic field, the free electrons inside it quickly rearrange themselves, canceling out any induced voltage. As a result, no current ever flows. About 200 years ago, Michael Faraday confirmed this through experiment, and scientists reached a conclusion. Generating electricity from Earth's magnetic field is physically impossible. Then in 2016, Christopher F. Chiba from Princeton University and Kevin P. Hand from NASA's Jet Propulsion Laboratory uncovered a hidden flaw in Faraday's experiment. It was something no one had ever questioned, let alone thought to change: the shape of the conductor. Scientists had always envisioned a solid conductor, but in truth, it didn't have to be. Chiba and Hand proposed a bold idea. What if we used a hollow cylindrical conductor instead? This structure was unique. It changed the very way the magnetic field passed through the conductor. In a typical conductor, free electrons could easily rearrange and cancel out the magnetic effect completely. But in a hollow cylindrical structure, the field isn't fully canceled. Instead, it twists through the conductor, creating distortions inside. These distortions ripple and form swirling currents, what physicists call a curl. It's the flux change scientists had long hoped to create, a continuous swirling shift in the magnetic field. This change generates a sustained voltage difference inside the conductor, and that means current begins to flow. It's a tiny gap, just a sliver in what once seemed like a flawless magnetic system. And through that very gap, we can begin to draw electricity, little by little, from the immense energy of Earth's rotation. But all of this was still just a theory. It had to be proven, experimentally. So they designed an experiment. They used a hollow cylinder made of a special magnetic material called manganese zinc ferrite. They aligned the cylinder so that it stood perpendicular to both Earth's rotation and its magnetic field. Then they connected a precision voltmeter to measure any voltage that might appear. The results were finally announced in 2025. Voltage had begun to appear in the cylinder. The team repeated the experiment in different locations and became convinced this was electricity, generated by Earth itself from its own rotation and magnetic field. It was the moment something long believed to be physically impossible was proven real. Of course, the power generated is extremely weak. Earth's magnetic field is vast in scale, but weaker than expected. And Earth's rotation isn't fast enough to induce strong electromagnetic currents. It might find use in ultra-low power devices or specialized environments, but it still has many limitations. This technology may never change the world, but it has already changed the way we understand the world, because yet another impossible has been proven possible. Science always begins at the wall we call impossible, the tiny crack that forms after knocking again and again. Someday, it will become a path, a wide open passage, clear enough for anyone to walk through without hesitation.